Then we're going to keep looking at positive rational exponents. So this will be day 2 of 7.7. And specifically, we're going to be talking about putting those rational exponents together. So I actually want to go back to the warm-up real quick and just kind of remind ourselves how we put fractions together. Because we're going to be doing it again, but just with them being as an exponent. So if you're going to add two fractions together, you need to make sure that they have a common denominator. And if they do, in this case they do, you're going to add the numerators and keep the same denominator. So this would be 5 plus 7, which would be 12 over 4. And then this fraction would actually reduce down to 3 over 1, or just 3. Now, if you go to part C over here in the warm-up, this has multiplication. That's actually way easier than adding or subtracting because they are the exact same. It doesn't matter if you have the same denominator. So if they're different, it doesn't matter. Multiplication is very nice and easy. You just go across the top, across the bottom, and do multiplication. So this would be 20 over 56. And you could reduce that if you want. We could divide them both by 2 and make it 10 over 28. And we could keep going, right? Reduce it by 2 again. I guess you could have done by 4. Maybe I'll do that instead. Divide both by 4. And that would be 5. And that would be 40 would be 10 plus 6. So we have 14. So that would be reducing the fraction down. Now, part B, if you're adding them together and they have different denominators, we have to make them the same. So actually, I should probably blow room here. And we're going to multiply them by a number that would make them the same. Now, what you could always do is you could just trade the denominators. So we could just say, multiply this one by 3 over 3, since that one has a 3. Multiply this one by 4 over 4. And then if you do multiplication, we're going to go across the top and bottom. So we would get 8 over 12 plus, go across the top and bottom, 3 over 12. Now we can add them together. So that would be 11 over 12 as an answer. Just a quick reminder on how to do that, because we're going to do it again, but we're going to do it with fractions, exponents. Okay, for today, how can I simplify rational exponents? So this is going to combine the properties that we did in 7.2 and 3 using exponents, but now with also being fractions. All right, example 1. Suppose y is greater than or equal to 0. Simplify this without a calculator. So you're going to probably have to go back to that chart that we used before. I'll open up real quick. This one here. Okay. So if this is in parentheses, that means the 4/3 has to go to both the number that's inside and the 9 that's here. So let's talk about the 9 that's here. If I make this into a 9 over 1, if you have a power to a power, you have to remember this is multiplication. So you're multiplying across the top and the bottom. So it actually is pretty simple, way easier than adding fractions here. So we go across the top. So this is going to be y to the 36 over 1 times 3 is 3. And that will get reduced. And then let's do this one, 64 to the 4/3. That's the new exponent now in the 64. Okay, if you remember from the section before, we split this up so we can use a table. We're going to do 64 to the 1/3 to the 4th. And then this simplifies to 36 divided by 3. That would be 12. Use the table, and we'll finish this one off. So we're going to look for the 1/3 on the table and find 64. Here's 1/3. 64 is down here. Look across. It's 4. So this turns into 4 to the 4th power. Still have y to the 12th. This kind of just keeps coming down with it. And now we'll read over what the 4th power is. So 4 to the 4th is 256, looks like. That's your answer. That one wasn't too bad. Again, you can use a chart, so we can do this without a calculator. So I'm going to allow you to use that table for the test or quiz or anything like that if we do like a non-calculator part. Example 2, simplify the following expressions into its simplest form. Okay, So now we have multiplication between two things, but what you would normally do is you would add the exponents, and we're going to just add exponents. So this one I can basically do going across the top. Because they have the same denominator, that's good. We're going to keep the same denominator. So we'll say this is x to the something over 4. Add them together, we get 10. And it says simplest form, so I'm going to reduce that. This becomes x to the, divide them both by 2. That would be 5 over 2. All right, part B. Again, we're going to add them. Unfortunately, they don't have the same denominator, so we have to make them the same. I'm going to multiply this fraction by, well, I can get it to be 6, right? If I multiply this by 2 over 2, that makes it 6. So really, I'm doing this work off to the side. I'm going to say, okay, it's 5/6 plus, and then go across the top and bottom here. That would be 4. Bottom is still 6. And then we would add across. So this would be 10 over 6, right? 5 plus 4, keep the same denominator. Reduce this down, and then we'll just say this is equal to y to some power. Divide by 2, you get 5 over 3. Now remember, this entire thing is in an exponent, so it should be small, and it should be up in the right-hand corner. Please don't write it like this. Right? It should not be down where the y is on the same line. It should be up in a corner. So even if you have to kind of angle your slash here for your division sign, that's fine. All right, in part C, if we have a number on top and one on the bottom, and we have exponents, as long as we have the same base, this is subtraction. So I'm going to rewrite it just showing that we're subtracting the fraction. So it's going to be 3/5 minus 1/5. And since they have the same denominator, we can just go ahead and subtract. So that would become 2/5. That one's actually really easy. So this is the same thing as saying r to the 2 over 5. All right, part D. We're going to do another one where we have to use the chart. So 2/3 is going to go to both of these. It's going to go to 27 and the 9. Again, make that 9 over 1. I like to do the variable exponent stuff first before I do the number. So the number, I'll just rewrite it as 27 to the 2/3. And then the exponent here, we have 9 times 2. Remember, this is power to a power, so you have to remember it's multiplication. 18, the bottom is 3. Reduce this. 18 divided by 3 is 6. I'm going to go ahead and do the chart for this one. 27 to the 1/3 raised to the second power. So 27 to the 1/3, here's 1/3. Go down, read 27. Across, that's 3. So this becomes 3 squared x to the 6th. And we should know what 3 squared is. That's 9 x to the 6th. That's your final answer. All right, part E. Again, you have to know your properties. So in this case, we're going to be adding the exponents together. Put a little plus sign there. Oh, that's really nice. We have the same denominator. That's really easy. So we'll just add the tops. So not a lot of work here. X, we're going to keep the denominator the same. Add the numerators, you get 6 over 3. We can keep going a little bit. 6 divided by 3 is 2. So even though we had some fractions here, this actually simplified to just x squared. All right, and then we have one more before the huddle. If there are numbers out in front of the variables, that's okay. So in this case, we have fraction times a fraction. So we actually have multiplication between the numbers. However, between the exponents, we would add the exponents because we're doing multiplication between the bases here. So the top here is going to be multiplication. We're going to go across the top. 1 times 6 is 6. 4 times 5 is 20. So that takes care of the numbers out front. And then, so that's a regular number. And then y to the power of, well, we have to add them. So I'm going to leave this blank and go off to the side and add these together. So we have 5/8 plus 3/4. How do we make the denominators the same? This is an 8, that's a 4. Let's multiply this one by a 2 to get that to be an 8. All right, so I have the same one. Just kind of put a little line here. 5/8 plus, this would be 6 over 8. Add the numerators, you get 11. The bottom stays the same. So their new fraction exponent is 11/8. Well, I guess I should reduce this one. We have 6 over 20. Let's do that. We can divide them both by 2. 6 over 2 would be 3. Divide that one by 2, you get 10. 11 over 8 cannot be reduced. That is in its simplest form. Okay, there's some huddle to do. A, B, C, D, E, F. I think you can do most of those. That'll be fine. Just remember when you're doing something like F, you're not actually changing the 49. It stays 49 to some power. You just subtract the exponents. So you're going to put a little something in there. And I know part C looks kind of difficult, but try your best. So this one actually has to, the 3 halves, has to go to everything inside. The 49, t to the 4th, the 9, the 10, and that 2. So it's kind of like distributing it to everything. I think I'm going to actually do that one, because all we have left to do is some graphing, and then we're done. So let's do that one together. All right, so 49 to the 3 over 2. I'm just going to put 3 over 2 to everything. The t to the 4th has to also be to 3 over 2. So I'm going to go ahead and let's erase some of these ones. It's going to go to everything. So let's make this 4 over 1, and then we can do multiplication here because we have a power to a power. So that's going to be 4 times 3, which is 12. The bottom will be 2. All right, now let's go to the actual denominator here. It has to go to the 9, so we have 9 to the 3 over 2. Has to go to the s, so that would be, make that 10 over 1. 10 times 3 would be 30. Doesn't really like my 3's too well. 30 over the bottom would be then 2. 1 times 2. And then we have another t here. We have 2 over 1. So 2 times 3 is 6. 2 and 2 gives you 4. I don't know if you noticed, but since we have t's up here, we could have actually subtracted first. But that's okay. We can do it later. All right, so this one is pretty long. Maybe I should do this part now. Or I'm going to reduce all the variables first. So this will be t to the 12 divided by 2 is 6. The bottom becomes s to the 15th. And then this is t to the 3 over 2. Oh, that's pretty ugly. I probably should subtract it first. All right, and this one you have 49 to the 1/2 raised to the 3rd. And then this is 9 to the 1/2 raised to the 3rd. So let's do both of those numbers. So 49, 1/2. So find the 1/2. 49 is a little bit further down. So that's going to give you 7. So the inside here is 7, and raise that to the 3rd power. 7 to the 3rd. Here's the 3rd. 343. 343. And the bottom here, we're going to do 9 to the 1/2. So 1/2, go down, find 9. That's 3. And then raise that to the 3rd power. So 3 to the 3rd would be 27. And the last thing I have to do, unfortunately, I have to do 6 minus the 3 over 2. So I can make that over 1. And we would have to change this to a 2 down here. So I'd multiply this one by 2 over 2, which makes it 12 over 2 minus 3 over 2. Same denominator now, so we get 9 over 2. So if we subtract that, we get t to the 9 over 2. Oh, I think I forgot something. Actually, I messed up. Back up. This one here, this one, 2 times 3 is 6. I forgot to multiply that to get 6. That's why I was wondering why it was going to be such a long problem here. This should be 6 here. My fault. And then the bottom would be 1 times 2, which is 2. Okay, so actually I didn't have to do any of the extra work, thankfully. I'm going to back up a little bit. It actually makes it a lot easier. I was wondering why this came out to be a fraction down here. So now you actually have 6 over 2, which is the same thing as just saying t to the 3rd. So maybe I'll just change that to t to the third. Yeah, I guess I kind of messed up the multiplication there. Here we go. Now it's a little better. Now you're going to do 6 minus 3, which is a lot easier not having the fraction. So that would also be to the third power. 6 minus 3 is 3. There's the final answer. That one just took a little bit longer because there were so many things that had to go to that 3 over 2. Okay, so that's doing one of the huddles. You guys can finish the rest of those. Let's talk about graphing rational exponents. So we're going to do a basic sketch of the following functions on a calculator. So you can put them into the calculator. I'm going to put them on Desmos so you can see what it looks like. We already saw what y equals x to the third looks like. I'm going to put that in Desmos though. Y equals x to the third. If you are doing it in Desmos, you have to hold Shift and 6 to get the exponent. So we're used to what this looks like here, that little shape here. I'm going to just draw it here. Just a sketch. But we do know it goes to the origin. Right here. Okay. Okay, so now we're actually going to do y equals x to the 1/3 as a fraction. So if you notice this could be written as 3 over 1. So what we did is we flipped it around and say, hey, what does this look like if we change it to 1 over 3? And then we'll answer how they compare. There we go. So let's just go ahead and go up here and change it. So I'm changing this to 1 divided by, you just have to hit the slash button that's next to shift, 3. So look what happened to it by changing it from 3 to 1 over 3. Pretty interesting. So now we have it kind of going sideways. We have it going like this. And this one's pretty hard for me to draw here. Not the best. Something like that. Close to that. So how do the graphs compare? Well, it looks like it's kind of like the same shape, although I wouldn't say it's rotated, right? If you can't rotate that, it's actually kind of like flipped. However, it does go through the same quadrants. So how would we say that? It's like kind of flipped over and then rotated, right? So you have to like flip this around and rotate. We could say that they go through the same quadrants. Seems like we had to do a rotation and flip. They the same go through the origin. A couple of things that are the same about them. And part D, these graphs are called inverses of each other. Why do you think? So the reason why these are called inverses, well, for one, if you look at 3 over 1 and you compare that to 1 over 3, you can see that they're called reciprocals. And the other thing is, if you were to draw specifically this line here, y equals x, I'm going to show you what it looks like. Sort of. I'm going to try my best, but it's not going to look that great. So if you were to draw a line, the y equals x, which it's a straight diagonal line like this, y equals x. It actually is a reflection across that. So I'm going to go ahead and put that in here as well. If I'm going to put it in Desmos, and you'll be able to see how it reflects across this line. It's called an inverse. So let's go back to that. So I'm going to keep that one in there. Now watch when I put this in here. Y equals x to the third power. So these are actually called inverses, where like if you were to draw a line through the middle here, and that'll be in my next one, I'll put that one in there too. Y equals x. Look at that. If you cut that line right down the center and it's diagonal, they look exactly the same. They match up perfectly. So if that ever happens, that's what makes something, these two graphs called inverses of each other. Kind of a new topic that we haven't talked much about, but there's kind of like an introduction to it. We're going to try another set. So what if we have x squared and x to the 1 over 2? And we'll see if these are inverses of each other and how they compare. Okay, so let's keep the y equals x there. And we're going to change these. So let's get rid of this one. Let's do x squared, which we know is going to be that happy face parabola, and graph that one. So we have something that looks like this. So what do you think this 1 over 2 is going to look like? If you notice what this one looks like, and we change it over to 1 over 3, right? If we take 2 over 1 and flip that around, what would this one be? Let's see. So I'm going to add another one in here. Y equals x to the 1 over 2. There it is. So it looks like it just starts at the origin and then goes up like this. See that? We don't see a bottom half here, thinking this might be like a sideways happy face, but we don't see it. Keep clicking on the wrong thing. So it kind of looks like this. So how do they compare? Still have a point at the origin, right? So this one is in only one quadrant. Only one quad. This one is in both of them. So why do we not see this down here? Like why, if we see it kind of like rotating on the side here like this, why don't we see this? Right, to see the happy face on the side. Well, for one reason, this has to be a function. So if you do something called the vertical line test, it would fail, right? If you remember, if you draw a straight line, it hits 2 points. If it hit 2 points, this would not be a function. And these graphs only graph functions. So it can't have the negative part here. Secondly, remember, you actually get two separate graphs. If you were to solve this equation when we solve squareds, we use square root, and we end up getting two answers. So not only do we need just x to the 1/2 positive, but we would also need negative x to the 1/2. And that's what gives you the bottom part of this. But it's two separate graphs. So are these inverses? Well, they kind of are, but we would need the positive and the negative. So let's go back to the graph and see. Okay, so I have the straight line here. I'm going to try putting the negative one in there and see what that looks like. Y equals x to the 1/2 again, but we want this one to be negative. So there it is. So now you can kind of see, oh yeah, if we were to draw this green line here and fold them together, they would match up perfectly. So it's kind of just only missing the other half to make it a perfect inverse. So it is almost. It's just missing the other half of the graph. So there is a huddle for you to try. You're just putting some different ones in and doing sketches and just doing a comparison of what they are compared to the ones we did before. So we're going to do 1/5, 1/4, and then see what this one looks like. That'll be it. Now we'll finish 7.7. This is day 2. There's only one more section left in this chapter.